Why are polynomials important for animation curves? Imagine watching a computer game or animated movie and seeing characters move so smoothly that you forget they are just images on a screen. Behind those seamless motions are mathematical tools called polynomials. They might sound complicated, but they are actually simple algebraic expressions that help create those natural-looking movements. Polynomials are expressions made up of variables raised to whole number powers, combined with addition, subtraction, or multiplication. For example, a polynomial could be as simple as 2 times a variable squared plus 3 times the variable minus 5. In animation, these polynomials help describe how objects change position, size, or shape over time in a smooth way. One of the most common polynomial types used in animation is called a Bezier curve. These curves are defined by control points, which are like anchors that shape the curve. The degree of the polynomial depends on how many control points there are. For example, a cubic Bezier curve has 4 points and is very popular because it can create complex, flowing motions while still being easy to compute. These curves pass through the first and less control points and are influenced by the middle points to shape the path smoothly. Using polynomials for animation offers many advantages. First, they produce smooth motions because polynomial functions are continuous and can be differentiated, meaning the movement can flow naturally without sudden jumps. Second, animators can control the shape of the curve precisely by adjusting the control points or the coefficients in the polynomial. This makes it easier to create specific effects or natural movements. Third, different degrees of polynomials can handle simple linear movements or more complex trajectories, giving a lot of flexibility. Finally, polynomial calculations are efficient, which means they can be used in real-time applications like video games without slowing down the system. In animation systems, polynomial curves are used to interpolate between keyframes, which are specific points where an object's properties are set. The polynomial fills in the values between these points, creating smooth transitions. For example, a characters are moving from one position to another can be described with a cubic polynomial, making the motion look realistic and fluid. Algorithms like Casteljau's algorithm use polynomial blending functions called Bernstein polynomials to build Bezier curves. This method makes the calculations stable and quick, which is important for rendering animations smoothly. In short, polynomials are essential for animation curves because they give a mathematical way to create smooth, controllable, and efficient motion paths. Learning about polynomials and how they work helps us understand how simple algebraic ideas can produce complex, lifelike movements in digital animations.